Good morning. Hi, I'm Vicki. There, that's me. I'm an engineering manager at Lyft. I'm super excited to be here at the first KubeCon in China. Last year at Berlin, I talked about how Kubernetes is a great choice for deep learning use cases. And this year, I'm super excited. We've come so far as a community, and I'm going to talk about why it makes sense for a company like Lyft, which has a lot more use cases. Lyft currently only operates in North America, so for those who are not familiar, we're a transportation company. Our ride-sharing services is available to 95% of the US population. The scale of our operations has doubled every year in the last few years. A couple months ago, we just crossed an important milestone of serving 1 billion rides. So to support the rate of our growth, our infrastructure team has built a great platform for running microservices. And I'm here to tell you all about the new generation of infrastructure that's based on Kubernetes. To give you an idea of our requirements when we were designing the Kubernetes platform, Lyft is heavily microservice-oriented. So we have over 300 microservices running in production, running on over 40,000 EC2 instances of various sizes, and they're all on our Envoy mesh network. Lyft is the birthplace of Envoy, and I'm going to talk about this a little bit later as well, but we've been on Envoy since the beginning, before the introduction of Kubernetes into our stack. So I'm going to talk about what that means for our migration as well. So in this talk, I'm going to talk about why we decided to go with Kubernetes at Lyft, and then talk about the challenges we faced when we were migrating at enterprise scale. So when we're designing the new generation of infrastructure, we really have to think about the use cases and the engineers that we're trying to enable and empower. So let's first talk about the use cases. At a modern tech company, you probably have a similar set of workflows that you want to support somehow. They don't have to be supported with the same solution, but they definitely have a lot of things in common. For example, observability, disaster recovery, developer tooling, health checking, the list goes on. They're also very different in nature, though. You're going to have a sad time if you try to ask your machine learning engineers to train models on a platform that's specifically designed to run microservices and vice versa. So if you decide to use the same foundation layer for all of these use cases, you have to provide very, very flexible building blocks. Now let's talk about empowering. I like to think about infrastructure as accelerating an engineer's productivity and allowing them to do their best work. To put it another way, especially in a large organization where you have many, many teams working on very different things, when does infrastructure slow engineers down? A lot of times, I think we slow engineers down when we require non-infrastructure engineers to understand the nitty-gritty implementation details of the infrastructure to perform some very simple task, like set up a web server. For example, maybe they need to understand what a cloud instance is and how to provision an auto-scaling group of instances. Then they need to think about how to configure these instances, such as what packages to install and how to update the dependencies. And then they need to run the service and then think about what happens next, like health checking, keeping it up. It was exhausting just to talk about it. So you're like, well, that sounds super ridiculous. Like, why would you make it so hard? You're right, you probably wouldn't, and you'd most likely build some abstractions over your infrastructure and provide tooling to cut away the overhead. Well, building abstractions is super hard. Your abstractions service area needs to be just right. If it's too large, you're running into the same problems. If it's too small, though, then it becomes a black box, and complete black boxes are undesirable because your users aren't empowered to help themselves. And you become the gatekeeper for support and feature requests, and you end up slowing people down anyway. So, and think about how costly it is when everyone's building the same abstractions. When you hire and onboard new engineers, you have to train them to use your own special sauce of abstraction platform. and that's a lot of work. And this is why at Lyft we decided to go with Kubernetes. It provides a reasonable set of abstractions for our infrastructure that is well supported by the community. Its API is flexible and extensible, so we found that it's a great foundation layer for all kinds of different workflows that we wanted to enable. Before Kubernetes came along, we actually started to introduce containers into our stack. It provided a lot of value into our development and test experience, but we didn't have a good way to run them in production until now. Cool, great, this is why we're all here. We just need to migrate the whole company over, and then we're good. Well, anyone who's done a stack migration at scale knows that this is a challenging feat, especially with young technologies. And so there we have it. Challenge number one is that it is a young technology still, and the ecosystem surrounding it is even younger. Kubernetes has matured a lot, and these days you can spin up a cluster on a cloud in minutes and deploy your service right away. So great, job done. Why am I here? Okay, so out of the box, Kubernetes gets you pretty far, but at enterprise scale, there's a lot more you need to think about when you're integrating a new technology. Do I know how to operate it? How does permissioning work? How do I monitor it? How do I integrate it into our existing observability and logging tooling? How can we guarantee our quality of service and recover from disasters? So as we started asking these questions, we introduced more and more and more onto our Kubernetes. So now, this is just a selection of add-ons that we use in our clusters. So how do we deal with this? We have an internal release process to verify that all our add-ons are compatible with each other and with our additions on top. We also have to make sure that we have observability into each and every component. We use Prometheus heavily for that, and we integrate it into our alerts and dashboards. It was a lot of work for the team to get to know each component, to know how to operate it, and know how to monitor. And we also work very closely with the community to address any bugs or scaling issues that we run into. OK, cool. So now we know how to run Kubernetes. Challenge number two is, even if we can run all of Lyft on Kubernetes, we need to think about how to best migrate the company over. How do we onboard engineers? It wouldn't be a successful migration if one day we just plopped the whole stack over, and then our engineers showed up to work the next day, and then they didn't know how anything worked anymore. So a straightforward way is to transition our engineers to a new stack with the old tooling that they're already familiar with. We make sure that the tooling is backwards compatible. For example, the deployment UI, the observability dashboards, all the little things that they're used to can still talk to Kubernetes. That way, they can be productive from day one. However, as we formed the vision for how our engineers will work in the new world, we started asking, well, how much of Kubernetes should we expose to our users? How much should they know about the underlying foundation? What we've decided on ultimately is that we're going to continue supporting tooling and abstractions over the kubectl or whatever it is that they're going to interact with, but we'll also allow access directly to the clusters for our engineers. So knowledge of Kubernetes isn't required for our engineers to be productive, but if they're already familiar with it, maybe from a previous job, from a pet project, or maybe they're just curious about it, or maybe they want to use some community-supported tooling, they can. And if they need to do something that our in-house tooling doesn't support, well, now they have a Googleable alternative. They can just use kubectl or build their own. Cool. Now our engineers are super productive. Everything runs great. The last challenge, the usual migration question. How do we actually turn the switch on? How do we monitor the migration to make sure that our metrics continue to look good, our services are healthy, it's easy to roll back? Just to give you a more concrete picture on how our microservices interact with each other, a single request at Lyft can go through up to 30 services. We need to be able to migrate services on every request path independently, so we don't have to worry about upstream and downstream dependencies. That way, we can slowly ramp our migration up. And so the solution we've come up with is to provide seamless routing between our pods and our EC2 instances at the networking layer. Our team wrote a CNI networking stack to do just that. And it's open source, so you can check it out and give us any feedback. So it's an overlay-free networking stack for running Kubernetes on AWS. This means that our Kubernetes pods are part of the same Envoy mesh network as our legacy stack. Let's take a moment to process that for a second. OK, so that means that our requests can go through our EC2 instances and our pods, and maybe across various clusters. And it would be totally transparent to the user and maybe even to our engineers. And we're able to do this because Lyft is already using Envoy. And so we just need to make sure that our pods can join the same network, and all the routing and service discovery is already taken care of. So here's a pretty picture with many pink boxes. As you can see here, our Kubernetes pod has a first-class IP in our virtual private cloud in AWS. Envoy is running as a sidecar container in our pod, and the pod appears just like any other instance on our network. And traffic can flow freely between the stacks, between various clusters. It's all transparent. This is great also because now we've invested a lot into our Envoy tooling, and our engineers are already familiar with those. So, for example, we get a lot of observability for free with Envoy. Here we have distributed tracing with Envoy, where the trace can cross between our different stacks, or even between different clusters, and it just works. There's zero additional effort from our engineers or from our infrastructure team, or even additional onboarding. Awesome. So where are we today? To wrap up, we're enabling and supporting multiple workflows already on Kubernetes at Lyft. A lot of our machine learning and batch jobs already run on Kubernetes. And we are in the process of migrating our production services. Today, our production traffic goes through both legacy and Kubernetes. And we're hopeful that we'll ramp up significantly next year. So maybe talk to me then. We look forward to working even more closely with the community through various open source projects. And thank you for having me.